I want to share with you something that I've been learning that I wish I knew before. So I'm going to talk to you about refactoring and code smells. So what is a code smell? Well, a code smell is it's a symptom. It's something in your code that is telling you that something is going wrong. When you do refactoring, there's code smells that's been listed that you can look for if you want to improve your code and your design. And what we're going to do today is look into the refactoring, the code smell, that's been listed in Martin Fowler's book, Refactoring. And we're going to go through all of them by categories. And I'm going to try and highlight what they are, what principles they break. And then together, we're going to refactor a piece of code and try to improve the design. Like I said, the code smells have been listed in Martin Fowler's book. And they're usually listed in categories. And one of them is the bloaters. So what is a bloater? Well, it's the methods, functions, classes that over time, they grow. It's like dust. You don't notice it's there. And after 2 weeks without doing any cleaning in your house, you come back and you're like, oh, wow, that's gross. So the long methods, code smell, for instance, is a method that is too big. So have you ever opened a source code and you look at a method that you know you might have to deal with, and the method is like 25 or 30 lines long, it takes 5 parameters, and it returns an int. And you're like, right, what is it doing, right? You try to find out. So here you have multiple things going on. You have a long parameter list. You have primitive obsession returning an int. Is that meaningful? You don't even know what that int means. And you have a long method that's probably doing too much. And long method and large classes, which are called gold classes, they usually go together. And they are violating the single responsibility principle, which means that this class and these methods are likely to change for many reasons. And you want to avoid that. So the main refactorings that you can apply to overcome this is usually extract methods and then move methods to where the responsibility lies. The other category of code smells, it's the object orientation abusers. So what does that mean is that these kinds of problems are wrong or unfinished implementation of object-oriented design. For instance, the refused bequest code smell is, for instance, a dog that is an instance of a chair because it's got 4 legs. And you're like, surely that's wrong. And it's violating the list substitution principle. And it means that it will have some behavior that you wouldn't expect, because obviously the behavior of a dog is not the behavior of the chair. One of the things you can do is to solve that problem is to use composition instead and have dogs and chairs has legs. The switch statement is so the switch statement is one of the customers that we're going to refactor together during the demo. Usually it's a missed opportunity. It's a missed opportunity to use the power, to leverage the power of object orientation, which is polymorphism, and apply a strategy pattern into your code. And usually the switch statement, the problem of the switch statement is that its existence in its own is the fact that it's breaking the open-close principle. Because when you want to have to implement a new branching on your code, then you will have to change, and you're breaking the open-close principle. The other cut-smell category are the change preventers. So when you take a story out of the board, you know you got something new to implement, a new feature. It's fairly straightforward. So you go to the base code and you kind of look around. And after 3 or 4 F12, like looking through the code, you realize, oh, wow. So that single new feature is going to impact 4 or 5 classes. That's the shotgun surgery. And you're like, OK, this feature is going to be problematic to implement. There might be a lot of regression. And that's where change has a bigger impact and a bigger cost. The counterpart is the diversion change, where it's like when you come to change a function in your class and you realize that you have to change many things inside that class. So it's like rippling change across one class. Right. So the other category is the couplers. Have you ever seen a code whereby you would have a collaborator calling, like a service calling its collaborator, and then asking the collaborator for its inner collaborators, and then asking that inner collaborators to calling a method on that collaborator? For instance, you would have the animal service, and you would have a dog class, and on that dog class you would call dog.body.legs.move. Why don't you just say, wrap all this behavior inside the collaborators and hide delegation, sorry. So that's the message chains. The message chains is like, it's violating the law of Demeter, which says that you should only talk to your friends. So don't try and expose the inners of your class, but instead encapsulate your behavior, encapsulate your collaborators, and expose behavior. One of the other cut smells that I want to highlight is the feature envy. So the feature envy is breaking the tell, don't ask principle. And one example of that is when you have a shopping service that would get the basket. So you want to add a new item to that basket. And in your add item to basket in your shopping service class, you would tell basket.items, and then you will iterate through these items. And then on each item, you will check whether the item is the same as the one you want to add. And you will either increase the quantity or add the new item. Surely it's not the shopping service responsibility to do that. So what you want to do instead is wrap this behavior into the basket class and say basket.addItem, and the basket will know what to do with it. One of the cut smell that is the counterpart, the opposite side of too much coupling is too much decoupling, and it's the middleman. So it's a class that its only purpose is to call another collaborator and to pass through messages. Why is it a problem? Because you add another level of indirection into your code. And by doing that, you confuse the developer that is trying to understand what's going on. The last category is the indispensables. So this kind of code is the code that's adding noise to your code base. It's a code that's either not doing much or not needed at all, but you have to read it. You have to see it every time you work with the code base. And so it's adding noise, and you waste time that you could save if it was not there in the first place. How many times have you opened a code base, trying to understand what the method was doing, going through all its inner algorithm, trying to understand who's calling it, and after 20 minutes of getting to, oh, I know what it's doing, so where, how? But it's never called. It's never used. You don't need it. That's dead code. So Dead code is kind of difficult to see, but if you have good tools that will help you, your IDE or some tools to help you refactor and write better code like ReSharper that I'm going to use with you during the demo, it's something that would be highlighted and grayed out, and straight away you can see that is not used, so you can see that you can remove it. Another thing that adds noise that's not even code is comments. So if you have comments and you want to explain what you're doing, then maybe you're missing out on something that is important, which is naming, name of your method, name of your class. So if you know what the class is doing and you see a bunch of comments, the problem with comments is it's quickly going out of sync of what the method is doing, because it's the last thing that people will maintain and rewrite. So you're better off just getting rid of it. So one of our other things that is breaking the you're not going to need it principle is the speculative generality. It's like, yeah, I have this feature to implement, but I know they must have missed something, because I know that this usually goes with this other feature. I'm going to put it there just in case we need it. Well, it's like bad code. You're not needing it now. Don't add noise. Don't add more code. The less code you write, the better you're off. And just remove that. So the dispensables is code that you can delete. And usually we are very afraid of deleting things, especially if we haven't written them. But the thing is, today, with all the version control that we have, we are fairly safe we can go back in time and retrieve the code. We don't have to command the code and to keep it anymore. It's like, so we have powerful tools to help us to have a cleaner code. So the idea is to use it. Right, so now I'm going to go down for the demo. And we're gonna deal with a switch statement, and we're going to see how to safely refactor existing code to make room for change and to make the change to that code easier. Like we said, we have to implement a new feature. We come in here. What we want to do is to add a new payment method to our system, and we want to be able to accept payment by Bitcoins. So here we already know that our system accepts payment by check, by card, or by direct debit. And after having looked through into the code and discussed with our fellow developers, we know that the payment service is where the change is going to happen. And we come here, and it's very tempting here to add a switch statement, to add a case in the switch statement, sorry, and to just do add our Bitcoin implementation of the payment and the execution of the payment. However, we want to clean that. We want to remove duplication, and we want to make sure that change is easier. We want to make our code more readable and more maintainable. So implementing a new feature is one of the good moments to do refactoring, and it should be part of the task at hand and not a task on its own. So here, what we're going to do, if we look at the pay method, we can see that it's very long. It takes multiple parameters, and here it's given the payment method, doing some logic, executing the payment and saving the transaction in the transaction repository. And here, it's sending confirmation. So it's doing two things, really. So what we want to do here is extract those two functions into separate functions, and so we can focus our attention into one responsibility at a time. One of the important things you want to make sure is you have tests when you do refactoring, because obviously you want to make sure that the change you're doing are not breaking your system. And here we have a tool called nCrunch that is running all my tests on the background. But otherwise, you would be running your test every time you make at each step of the refactoring and committing your step by step. So here, first thing I want to do is extract the method. And rename it to send the confirmation email. And then what I want to do is extract this into an execute payment method. And so here we can come and focus on the logic that's happening when we want to validate the payment and save the transaction. So here what we know that we want to lean towards polymorphic implementation. So what we are going to do is to extract each branching into a method and then make those methods look similar so that slowly we can see the pattern emerge, and then we can apply polymorphism to this algorithm. And here, sorry, I just we notice that this method is taking 4 parameters. We have the amount, the customer ID, the order ID, and the payment method. And we see that they are used and go together along. They seem to make sense together, and it looks like a data clamp. So one of the things we can do is group them together in a meaningful class. And to me, this looks like payment details, right? So I'm going to extract class from parameter refactoring. And I'm going to create my payment details class. I'm going to put it on the top level. And so here we go. We have a execute payment with payment details. Then, as we said, we're going to extract each branch in its own method. So we're going to do extract method. And we know that we are executing the check payment here. So we come to this guy here, and it's going to be the same. We're going to extract the method and execute a card payment. And here, we execute the direct debit payment method. So here we can see that all these refactorings have been done in green, and we're not breaking anything. And we're doing small steps. So here, since I know that I'm going to go through towards a polymorphic implementation, I know that I want this to be moved to another class. So first, I need to make it static to be able to safely move it using ReSharper to another type. And I'm going to do the same for the other 2 methods. To be able to do that, we're going to pass these guys as parameters. Because in our design, they are collaborators of the payment system service. So ReSharper has several sets of shortcuts that you can use. For the moment, I'm not using the shortcuts so that you can follow along what I'm doing. So here I want to make this static. And I know that I'm going to move it out, so I just can make it public now. But you can make it public when you move it to another type. So, sorry, let's focus on this one, sorry, direct debit. Then the refactoring we do is extract class. And we're going to create a new class. That is the direct debit payment. With moving that method into that class. Then same here. We make it static. Sorry, yeah, it's good. So ReSharper is good enough to tell me, hey, this guy is going to cause you a problem later, so just make it as a parameter. Then I make it static, public, and I move to another type, which is the card payment. Same here. Introduce parameter. We make the method static. We make it public. And we move it to its own class, which is a check payment. So here we kind of see the pattern emerging. We have the check payment, the card payment, and the direct debit payment. And what they do really is they execute the payment given that payment method in their own specialized way. So we're going to make those methods look similar to be able to move it and apply an interface. So to make it, I'm just passing this into the check payment method so they have the same signature. So next, what we want to do is rename the method, because if we look here, it's pretty redundant. Check payment, execute check payment. So we can fairly say that we can rename it to check payment execute. Same for here. And here, the same, we're going to rename it to the same name. Direct debit execute payment. Right, so here we have static methods, and what we want is a method of classes. So here is a little trick to make ReSharper suggest to you to make this static method a method of a class. So we're going to just instantiate this check payment, and then make method execute non-static. Right? And then what we want to do is we want to have a base class variable that, given the payment method it has, will get the correct subclass and execute the correct payment. So in order to do that, we're going to introduce a variable that we're going to give it the iPayment type, and we're going to create this interface. And so ReSharper is asking us to make this implement the iPayment, which is exactly what we want to do. And we're going to add the execute payment to the interface. So here we got our interface that's got this execute payment. And eventually what we want is all the payment types to inherit from iPayment. And we're going to go towards this by, so here what we want to do is to move our variable outside the switch statement. And first let me just rename it because it's going to make more sense. We're going to split the declaration and the assignment. And move this out. So here, it's a bit redundant, but we're going to do the same for the following two payment types. So we have the next card payment that we want to have a method of a class. So we make it non-static. Then we're going to introduce the variable. And this time we, up. And here it's complaining. We're going to make the card payment implement the payment interface. So that we're good. And same here. We want to make this method of a class. Introduce a variable. And make direct debit implement iPayment. So here we a little step, always staying in the green, even though it was not compiling, but for a very few seconds. But we got, with this tool that is running the test in the background, we got good feedbacks on what we are doing when we are doing it. And here we really see our implementation coming to live, and we can see we have here now duplication. We have payment.execute. And what we can do is move this execution outside the switch statement, because here our logic will get the right subclass for the job at hand. And when we call the execute payment at runtime, we will know which one we are dealing with, and what's the algorithm that is called behind. So this move is slightly less safe than the one we've been doing, because we have to move this guy out of the switch and then delete this guys here. And for the compiler to be happy, we're just going to instantiate this, this payment object as a null for the moment. And here we can see that we now have what we want, the decision whether of the payment method, is done here in our switch statement, and then we execute the payment. So really, what's happening in the switch doesn't seem to be the responsibility of the execute payment method. So again, this is something we want to look to move out. So we're going to extract a method, and eventually the payment service is not responsible to know which subclass to get from the payment method. So we're going to move it to the type responsible for that, which will be our payment factory. So here we come here, and we extract the method. And we now have payment with payment details method that's going to retrieve the right payment object. And we're going to make this guy public because we know we're going to move it to where it belongs. So here it's complaining because the interface was not public, so we make it public so that it has the same access right. And we just move it to our payment factory. So here what's going on is that we have now moved all our logic to get who is responsible for what to our payment factory. And we are leveraging polymorphism in our payment.execute method to deal with the execution of our payment. And we have now made our code more open for extension and closed for modification. Why did we do that? So if I open the payment factory, we can now see that anytime we want to add the new payment method, we have a single point of modification where we're going to here nicely introduce the new Bitcoin payment method. And we're going to have our new Bitcoin payment implement the iPayment interface. And we are going to create that new subclass without having to change the other payment method. So we have less room for regression. And our code is easier to extend. So hopefully by now you're convinced of the reason for refactoring, that by having moved our switch statement into a polymorphic implementation and having made our design more open for extension so that we add a feature by adding new code instead of changing existing one, we are decreasing the cost of change and we are making the code easier to understand. So the question then is when to refactor. So if you do test-driven development, refactoring is part of the 2-minute cycle. So you make the first failing test, you write enough code to make it pass, and then you refactor your code. Whenever you make a room for change, like we did now, if we wanted to implement a new feature, the refactoring is part of the task of implementing that new feature. Same for when you fix a bug. So if you go through your base code and you have to change it to either fix a bug or implement a new feature, that's a good way of a good place to do the refactoring. And when you do code reviews, code reviews and pair programming, if you do the code review with the person who wrote the code that you're reviewing, it's easier straight away to do the refactoring with that person as you pair program on that code review, if you can. When not to do refactoring, so first, you don't do refactoring if you don't have tests. Refactoring is making your code better, but it's improving the design of your code, but without changing its behavior. To be able to be sure that you haven't changed its behavior, you make sure you have tests. So don't go away tomorrow and refactor everything. So make sure you have tests, make sure you're always green, do small steps, and do not refactor if the code doesn't need to change. Do not refactor if the code works. Don't do refactor for the sake of refactoring. So if you want to know more, and obviously I recommend you read the refactoring book from Martin Fowler. And my colleagues at Codurance, they've put together nice resources. So we have a blog post on code smells if you want to know more. And Matthew Butt, he's a very skilled developer, and he's got some nice ReSharper. I don't want to use the ninja metaphor, but he's really great at ReSharper and refactoring, and he's done screencasts, and you can like follow along with simple steps how to improve the design of your code safely. And thank you. And also, I want to say, I've been trying to, during my apprenticeship, I'm working on my refactoring, and this is C#, sorry for the Java developer, but we have a great tools for refactoring and ReSharper, so if you want stickers, it's amazing. I've been trying to do refactoring in JavaScript. It's less painless. It's more painful. So we got great tools, and really, the idea is to learn how to use them, to make the best of them, to make our life easier, and to make our job, to love more our job. So, thank you.